Hello, hi everyone. I'm Aman back with another beautiful problem on binary trees. So the question is, we are given a source node. We have to calculate how many nodes are there at a distance k below that node. Okay, so this time we are not given the root node, we are given the source node, and we have to tell from this source node how many nodes are there at distance k. For example, if k value is 4, how many nodes are there at distance k below this one? So 1, 2, 3, 4, this node, and the other node. Distance is calculated by edges, so these two nodes are in fact y2. I think we have more than two. 1 2 3 4, this is 1 1 2 3 4, this is 1, then 1 2 3 4. So this one, we have three nodes at distance k below our node. This is what we have to figure out, and again we are given that corresponding node. So what do we do? From this source node, I want to calculate how many nodes are there at, let's just say, k equal to 4 distance. So I will ask my left child, hey left child, tell me how many nodes do you have at a distance 3 away from you, 3 below from you, left and right node. Now this node will ask its children, hey both of my children, although it has only one child, tell me how many nodes do you have at a distance k equal to 2 distance away. This one will ask its children, how many nodes do you have at a distance 1 away, and this will ask its children, how many nodes do you have at a distance 0 away. Now when this node is asked how many nodes it has at a distance 0 away below this one, so it means what? We are talking about this node. So this node will do what? This node will return 1, this node will also return 1. This node was asked how many nodes it contains below it at a distance 1 away. Left child said 1, right child said 1, so it will return what? 1 plus 1 2. This k equal to 2 will return what? 3. I mean, you can understand it this way also. This k equal to 2 must have also asked its right child, hey right child, which is null, how many nodes do you have at a distance k away? Since the node was null, that node returns 0, and this will return 2, the same 2. This will return the same 2 again, correct? This said you are talking about me, so it will return 1, it will return 1, this will return 2, this will return the same value, this will return the same value. Now when we were here, we were calculating how many nodes does this node contains below this one at a distance 3. It will ask this its children, so we'll get for this node at k equal to 2, for this node at k equal to 1. When it will ask its children, they will we will see there is no child, so they will return 0 0, so this will return 0. Now coming to this node, this will be asked how many child do you have at a distance k equal to 1 away below you. This will be asked how many nodes do you have at a distance k equal to 0 below you. K equal to 0 means what? This node will say, okay, you're talking about me, so I'll also return 1. So we'll return 1, this will also return back 1. This node will say, okay, I was asked how many child do I have at a distance k equal to 2 below me. Left child said 0, right child said 1, so I'll return overall 1. This node will also return 1. Now this node asked what? Hey left child, tell me how many nodes do we have at a distance k equal to 3 below you, and the same to the right child. Left child said 2, right child said 1, so this will return what? 2 plus 1, 3. So we have these three nodes. Coming to code part, code is going to be relatively very easy. The same thing, I will ask my left child, hey left child, tell me how many nodes do you have below you at a distance k minus 1. Hey right child, tell me how many nodes do you have below you at a distance k minus 1, and I'll return L plus R. When if k becomes 0, it means what? I am at a valid node and you're talking about me, so I should return 1. I mean, when I am here and you're at k equal to 0, you should return 1. Although there should be a base case before that, that if node is null, is double equals to null, we have to do what? We have to return 0. So I mean, when you reach a null node, you return 0. If you don't reach a null node and distance is 0, it means you're talking about yourself, so you'll return 1. Hope it clears to all of you. Now coming to time, this source could be anything including root. So in the worst case, you need to travel the whole tree, so time complexity will come out to be order of n. While talking about space, I mean, at one time these many functions, or let's talk about this s, this was the source, these many functions were there on the stack. Now once this was removed, this was added on the stack. I mean, this function called this one, which called this one, which called this one, which called this one. Once this got removed, this function got added. The same we do in any pre-order, in order or post order. So space will come out to be order of h. So we have another variation of this question in which we calculate how many nodes do we have from a given node at a distance k away. I mean, here we calculated only the nodes which are below at a distance 4. There we'll calculate what? How many nodes do we have from this node at a distance 4 away, and it could be from any, it could be in any direction. So 1 2 3 4, this node will also be counted. 1 2 3 4, this node will also be counted. 1 2 3. Okay, this side we don't have anything, so we'll do that question after this one, but this is a prerequisite for that question. So hope you got it, and thank you so much.